If a is less than 1, show that integration from 0 to pi log of 1 plus a cos x by cos x dx is equal to pi sine inverse a. Here we see that there are two parameters, a and x. So here we have dx, then let phi of a be 0 to pi log 1 plus a cos x by cos x dx. This one is equation 1. Now what do we do here is that we differentiate equation 1 with respect to a parameter a. That is phi a equal to d by dA of 0 to pi log 1 plus a cos x dx by cos x. So if we take this one under the integral sign, then it changes to this sign. Okay, here we have to differentiate with respect to a, then x would be a constant. So 1 by cos x we can take it out. Now we differentiate log of 1 plus a cos x, and that is equal to 1 by 1 plus a cos x into the differentiation inside the bracket. Differentiation of 1 is 0, and differentiation of a cos x with respect to a we have cos x. Okay, then further we have phi prime a 0 to pi dx by 1 plus a cos x. We know that cos x is 1 minus tan square x by 2 by 1 plus tan square x by 2. Next we take LCM. When we take LCM we have integration from 0 to pi dx. So 1 plus tan square x by 2 into 1 we have 1 plus tan square x by 2 plus a into 1 minus tan square x by 2. Okay, divided by 1 plus tan square x by 2. Now this one comes to the numerator, and we know that 1 plus tan square x by 2 is secant square x by 2 dx. 1 plus tan square x by 2 a into 1 a into tan square x by 2 we have a tan square x by 2. 0 to pi secant square x by 2 dx, and then you take tan square x by 2 together, we have 1 plus a together, and we have tan square x by 2 into 1 minus a. I hope it is clear. Hence we have secant square x by 2 dx 1 plus a plus 1 minus a tan square x by 2. Now we divide numerator and denominator by 1 minus a, so that there will be no 1 minus a with this tan square x by 2. Okay, so upon doing that we get 1 upon 1 minus a, and here we have 1 plus a by 1 minus a. Now here there will be no more 1 minus a since we have divided by 1 minus a. Okay, and in the next step here we put 2. Since we have put 2, then we have to put here half, so that they will be cancelled and we come back to the original one. Okay, and for this one we put under a square root along with a square, and tan x by 2 whole thing square. Now for this one, look here, see, phi prime a equal to 2 by 1 minus a integration from 0 to pi. Now why I put d of tan x by 2? Because I know that differentiation of tan x by 2 is half secant square x by 2 dx. Okay, hence I have in this way. Now for this one, you can treat it as integration of d. You can treat this one as x, this one as a constant a square plus x square. Then what is the integration of this one? It is equal to 1 by a tan inverse x by a. Hence you apply this formula here. Then we have 2 upon 1 minus a into 1 by a. 1 by a. What is a in this case? Root over 1 plus a by 1 minus a. Tan inverse x by a. Tan inverse, what is x in this case? Tan x by 2. Tan x by 2. Tan x by 2 by a. Or a here is root over 1 plus a by 1 minus a. The limits of integration are from 0 to pi. And then we have 2. Now this root over 1 minus a comes to the numerator. Hence we have 2 root over 1 minus a. And in the denominator we have 1 minus a into root over 1 plus a. Now you put the limit tan inverse tan of pi by 2 divided by root over 1 plus a by 1 minus a minus tan inverse tan of 0 by 2 divided by this. And then we have, look here, this whole thing will become 0. Why? Because tan of 0 by 2 is 0. What about this one? Tan of pi by 2 is infinity, and infinity divided by this one is infinity. So tan inverse of what angle? You'll get infinity. Tan inverse of tan of pi by 2. Tan of pi by 2, you'll get infinity. Hence you get pi by 2. So now here this can be cancelled with this. Okay, and you have pi of root over 1 minus a by 1 minus a into root over of 1 plus a. And then now you rationalize the denominator, that is multiplying numerator and denominator by root over 1 minus a. So in the numerator, here you'll get root over 1 minus a into root over 1 minus a, which is 1 minus a. This 1 minus a gets cancelled with this one. Hence, you have pi and root over 1 plus a into root over 1 minus a. It is root over 1 minus a square. Let this one be equation 2. Now, you have to integrate equation 2 with respect to a. So, once you integrate, you'll get phi of a. Pi integration dA root over 1 minus a square. What is the integration of dA root over 1 minus a square? It is pi sine inverse a plus an integration constant. Now the next step that you have to do is you have to find the value of c. Now look here. You put when a equal to 0, your c is equal to 0. How? Just have a look here. Once you put your a 0, then 0 into cos x, you have 0. This is a constant and log of 1 is 0. Hence, you'll have phi a to be 0. Okay. Then, if these are 0, then c is 0. Hence, your phi a is pi sine inverse a. Okay. Which implies that from the beginning we have assumed that phi a is equal to this one. Is it? Then we conclude that integration from 0 to pi log of 1 plus a cos x dx by cos x is equal to pi sine inverse a. Okay.